Good morning and welcome. My name is Stephen Oliver, and thank you for joining the part 3 of a complete Vicor webinar series on high voltage DC. The first two seminars were an overview of high voltage DC in various industries, and the second one was a look at the key power conversion blocks for high voltage DC. Today we have the start of a special guest presenter series of seminars. Today's topic is on 380 volts in the data center and will be presented by David Moore, who is a distinguished technologist and power systems architect at Hewlett-Packard Corporation. David is currently a member of Hewlett-Packard's technical staff supporting the HP servers group. As power systems architect, he is responsible for the development of power technologies utilized in the information technology products produced by HP. This includes emerging technologies such as HVDC and rack-level distribution. He has more than 25 years' experience providing power conversion from processor to building level. David joined Hewlett-Packard in 2006. Prior to that, he was employed at Artisan, which was bought by Emerson Network Power, and earlier at designing power supplies for aircraft defense systems at Northrop Corporation. Now I'll hand over to David. Thank you very much, David.
Thank you very much for that introduction, Steve. Hello to everyone out there. Good morning, good afternoon, wherever you happen to be. Today's seminar is 380 volt DC ecosystem development, data center focus. This presentation was first done at Intellect. I presented there last fall, and I had several other contributors, David Geary, David Owen, Maurizio Saltano, and Vijay Sonnenberg. So to start this off, there's been a lot of discussion about why we would want to do 380 volt DC distribution within the data center specifically. Started with a lot of interest in efficiency, the possible gains that could be had there, and there was a lot of initial hype about how much efficiency could be gained in the data center. Looking at today's structure, the advances that have occurred in AC as well as DC, I've come up with a graph or a chart here that has a bit more of a realistic combination of a number of different studies and present some rounded data from different things, different studies, different demonstrations within the industry. So looking at the opportunities for improvement within the data center, everyone's interested in their CapEx reductions. So, trying to eliminate components or pieces within the power infrastructure of the data center. Utilizing 380 volt DC, there's two large areas where we can simply eliminate circuitry from the pathway. The first one in the distribution is the elimination of upstream inverters in the UPS. So taking that AC input from the data center and going straight to a DC distribution. And then the second big area would be removal of the power factor correction circuitry within the power supplies of the IT equipment. And then there are some easily had gains with reduced copper in that DC infrastructure. It's possible to deliver the same amount of consumed power with a reduction in that copper used in the distribution. And then there's your ongoing OpEx reduction, primarily, again, starting with the efficiency gains. Looking at today's structure, it's relatively easy to get 5% of gains in compared to an AC distribution structure. 10% can be had depending on the type of distribution and upstream infrastructure that's currently in use. Distribution losses, again, come from that copper, better utilization of the copper. And then DC structures have an increased reliability factor to them. And these numbers are based on a number of telco distributions, long-term studies there, and a study done by EYP, Mission Critical, which is also an HP entity, demonstrated a greater than 200% increase in reliability of a DC system. Then, primarily at the data center footprint, it's possible to reduce the overall volume of the data center. So looking again at that IT contribution, eliminating the power factor front end on a typical power supply would achieve up to a 50% reduction in space. Looking at the overall data center, savings in from the UPS side, distribution, things of that nature, it's also easy to achieve a 25% reduction. And then there's a number of power quality improvements that are easy to be had. Looking again at that power factor and harmonic content that a typical IT power supply produces, using DC distribution, those harmonics and poor power factor, those types of items are eliminated within the data center and are controlled at the point of where DC is created. So if there's a number of rectifiers used or a very large single rectifier, that device can handle the harmonics, power factor, and power quality items right at the point at the grid. So it's combined and easier to control there. Then there's also, depending on implementation of the high voltage DC rail, there's a number of ways to add backup energy, battery sources stacked right on that rail, alternative energies connected at the DC point are easier to implement and have a much simpler distribution method. To look at where some of this data is coming from, this is just some of the worldwide DC deployments of DC. These are all either telco or data center applications. Primarily from a large deployment perspective, the majority of the production facilities are in Asia, and the majority of those facilities are 240 volt DC. Primarily the China telecoms have been implementing 240 volt DC distribution for some time. They've got a large number of deployments that demonstrate the practicality of that. And then now here where I'm located in North America, there are a number of proof of concepts that are going on and a few smaller production demonstrator type of applications. So there's a number of studies being conducted both in North America and Europe to better utilize some of the emerging components that are being developed. So what I wanted to do with the rest of the presentation today was focus on the equipment within the data center. So looking at the availability of equipment today, looking at the AC facility distribution that's connected to the grid as it always has been. There are options for backup generation of power, either diesel generators or other means. And then I'll focus more on the power system on the inside of the data center. So how the DC is created, how it's distributed, and then how it is utilized inside the rack itself. We'll also talk a little bit about the standards, some of the componentry, and how they've been qualified to these standards. Here is a sampling of the componentry that's currently available from a DC infrastructure. And from this slide on, I'll be talking primarily about 380-volt DC targeted products. The 240-volt DC in China is an early deployment of the DC. My opinion is that the rest of the world is migrating more towards 380-volt DC distribution, whether that be a positive voltage, negative voltage, or a plus and minus 190 with a center tap. So from a DC power systems, that generation of that high voltage DC, there are a number of partners that you can choose to work with to take your facility incoming AC, that grid connection, and convert to DC. Emerson, ABB, Delta all have very large deployments to demonstrate their products. They've deployed in a number of locations. Their product lines are fairly mature. Going down through the distribution a little bit more, the DC breakers, listing a number of componentry there. And you can see then going into distribution and power supplies at the IT loads. I've got further slides on many of these components, so I won't dig into those real deep at this time. But at the ICT, the load end of it, for a number of the customers that are out there today, several major manufacturers provide high voltage DC enabled equipment, and I'll touch on a couple of those as we go through the rest of the presentation. So I'm actually going to start at the ICT load and work my way back to the data center level DC creation. Looking at either your top of rack switch or network equipment within the rack, Juniper Network since late last year has had 380-volt DC network products supported. They have a 850-watt power supply that runs at 94% efficiency. It is a wide-ranging product, so it will work at the lower end of a DC distribution to that nominal 380. They have standardized on the APP safety grid connector, and that is a popular part within the industry. Juniper does have plans to expand that product line, so early in 2014 they will be offering additional products within that line. One thing to call out, because the power supply is a wide-ranging supply, you can see from the efficiency curves in the lower right-hand corner that there are some gains with this product, and I'll demonstrate later that additional gains can be had with other products in the marketplace. HP's product support with 380-volt DC. HP has what's called a common slot philosophy. We developed a form factor for a power supply that is utilized in